Evening, everybody. So I'm going to follow my colleagues and tell you more about elephants and also sharing some tracking data to show you how smart they are. But just as an introduction, so elephants are born with 35% of their adult's brain capacity, whereas for humans, it's 26%. And for most other mammals, it's actually 90% of their adult brain weight. And they also have brains 3 times the size of humans, but it's still only 1/10 in proportion to their body size. But what it means when they are born with a fairly small proportion of their adult brain weight is that they've got this long period in which they need to learn and be involved in many complex social relationships, and also, as Mickey has so beautifully told us, vocalizations, complex ways of communicating, so that they can eventually become really smart adults. And elephants have passed the self-recognition mirror test. So work done by Dr. Poltnik has shown that Asian elephants, and they've also done these experiments on African elephants, when they are shown a mirror and a reflection of themselves, but also there were these white crosses painted on their forehead. Like most other animals, they would probably try and find the animal behind the mirror, but no problem to the elephants. They passed with flying colors, and they were even looking around the enclosure and trying to rub off the white crosses of their foreheads. So that just shows you that they can self-recognize themselves. Then there were some wonderful experiments done by Dr. Frans de Waal to prove that elephants have cooperative problem-solving abilities. So once again, the experiments were on Asian elephants in captivity, and what it involved was a crate with reward food and a rope that was strung around the crate. And elephants had to cooperate to bring that crate towards a barrier so that they could actually eat the food. And one elephant was let out onto the experimental site at a time, and they waited for another elephant to come. In some instances, they would call another elephant to come and join, immediately understanding that there's no ways they could get this reward food unless they cooperated with each other. So they would then, the other elephant would join, and they would together pull the rope closer, pull the rope with the crate closer so that they could access the reward food. But the amazing thing about this experiment is that the elephants actually outsmarted the scientists that put this experiment together, in that the one elephant that was a bit smaller realized that, yes, I do want the reward food, but it's pretty hard work to pull this crate, and I can't do it by myself. But what I can do is I can just passively stand on the rope and let the other elephant do all the work, and I can still access the food. So that just shows you how smart they are. There were also other experiments done on Asian elephants, where they were taught via a touch screen to be able to show that they have a numerical ability to understand different quantities. And this is really important when we think of crop raiding. If they can quantify the benefit of, say, now reward food, they can probably do a cost-benefit analysis in terms of, should I risk it to go and get that tasty morsel? Is it safe enough? Is the reward going to be big enough for me? And then they have this incredible ability to retain information. And as Lucy so beautifully illustrated, they've got these very strong social bonds. And Cynthia Moss recalls an amazing event that she witnessed. There was a female elephant that had died, and she would keep all the jawbones of the elephants around her research tent. And the female that had died was actually the matriarch of the herd. And every time that family came past her tent, the daughter would break away from the family and walk straight to her mother's jawbone. So they could recognize the jawbones of a particular individual that they felt really close to. And then Cynthia shuffled that jawbone to see how good was this particular elephant at recognizing her mother's jawbone as opposed to the others. And she would just continue with a beeline straight to her mother's jawbone and go and pay respect to it. So that shows you not only how wonderful their sense is in terms of smell and recognition, but also their memory. We've done a lot of work in the associated private nature reserves to the west of Kruger National Park. And we've been following this one individual called Classic for about 20 years. And it's been fascinating to follow him over such a long term because he was probably born in these private reserves to the west of Kruger. And the fence between the private reserves and Kruger was removed about 30 years ago. But Classic, as you can see from those blue dots, spends most of his time in the private reserves. Only the last couple of years of tracking him has he actually ventured into the Kruger National Park. And what we've seen is he's also only done that when he's in must and he's full of testosterone and he's braver than usual. So elephants retain a memory of where these barriers are, and often these fences, I like to refer to them as ghosts of fences past. So animals remember where these fences are, and even though you might take down a fence for management reasons, there might be some individuals that will take a really long time to cross those barriers, even though they might just be virtual after the fence has been removed. Then elephants are really clever at using tools to overcome obstacles. So we've had plenty of experience, and I'm sure other people that work on elephants have seen that bulls with particularly beautiful tusks can use their tusks as tools to snap electric fences as though it's spaghetti, because they've learned that their tusks don't conduct electricity. They've also learned that sometimes it's much easier to push a younger bull through the fence, let the bull get the shock, and they'll just walk afterwards if it's an older individual. So they certainly know how to problem solve. And I'm sure a lot of you received this video of this bull in Addo National Park. So they put a high-strand electric fence around a waterhole to prevent the elephants from drinking. But this bull wasn't going to accept that. He didn't particularly want to receive an electric shock. So no problem to him. He started leopard crawling below the electric fence. And then as soon as he was past the point of being electrocuted, he just stood up and went to his favorite waterhole and drank water, and then leopard crawled out again. So because elephants have this memory, they do look at past experiences in terms of how they've had interactions with other animals and specifically with humans. So a lot of elephants have learned that humans are their greatest enemy and we threaten them more frequently than other species. And how do we threaten them? We can disturb them. So yeah, we've got on the top section of the slide, you can see a graph where we've got proximity versus time. And this graph is the movements between two bulls. The one bull is called Ian and Snap. They were both collared on the same day in June. And even though collaring operations can be quite disruptive, I mean, it's helicopters and it's one elephant going down and then it's finding the other elephant with a helicopter and also putting that elephant to sleep to put a collar on it. The collaring operation, so you can see it started in June, did not separate these two bulls. They were so close together, they hardly moved away from each other. They were always in sight of each other. Then in August, one of the bulls got trapped inside a smaller property, other side an electric fence, and then they couldn't have that very close association, as you can see from the graph. They would still come to the fence and greet each other and try to stay as close as possible to each other, but obviously the fence was disrupting that very close movement. And then something happened in November to displace the bull that was trapped in the reserve, or in the fenced area. and he took off into Kruger, but it didn't take long. And this comes back to Mickey's presentation on the communication system for the bull that suddenly was missing his companion to start heading north to go and look for him. And at the same time, they turned around to meet each other halfway. So I'm going to show you the map of the tracking data. So that red star depicts when there was a disturbance to the bull called Ian, and he basically took off. So after being trapped in this small property, and he took off and he ran 123 kilometers in 5 days to the north, close to Letaba in Kruger. And after about a month, his companion realized, but my buddy is gone and I better go and look for him. So he took off north and he went into Great Letaba Ranch, which is a smaller reserve to the west of Kruger. But miraculously, both bulls decided to turn around from where they were and meet each other on the same day, which just reinforces this communication system that Mickey was talking about. What we also see is that because elephants know that we are their greatest enemy, they learn with time how they should adapt to the environment. So these graphs are depicting the north of Kruger National Park and the north of Limpopo National Park in Mozambique. So Limpopo National Park is in Mozambique and Kruger is in South Africa. And that blue area is just defining the greater home range of a particular individual, although we saw this with a lot of animals that we collared in the north of Kruger. And the darker blue areas are their core range. And before the ivory poaching, so the pre-poaching peak in 2012, a lot of these elephants were moving into Mozambique, into Limpopo National Park. Then the poaching picked up, and suddenly what we saw was that the elephants contracted their range back into Kruger Park where it was safe. So they've got a very good memory of where it's safe and unsafe. What we've also seen and what many people know is that fear makes elephants nocturnal. So here's a map showing once again that same study area that we operate in. So we've got the private reserves to the west of Kruger, then we've got Kruger National Park, then we've got Limpopo National Park in Mozambique. The red tracks are depicting movements during the day and the blue tracks are depicting movements at night. And if we look at the ratio of day to night movements, in the safer area, it's almost 50% day and night ratios. As soon as you start moving towards an unsafe area, elephants become nocturnal and you're finding far more movements at night. And once again, with an intelligent species like animals and a risk and adventurous species like elephant bulls, they're far more adventurous than females. This nocturnal behavior often changes them into becoming thieves at night. So elephants have learned that when we're sleeping, we're not going to be chasing them around and threatening them. So if they want to steal something from us, they better do it at night when we're sleeping. So these are the tracks of an elephant called Joel, who was collared in Mozambique. And you could see there's a lot of movements at night, the blue tracks, but then the elephant comes into South Africa at night and steals sugar cane from an area in Kapati Poort where there's quite a lot of sugar cane fields. And then as soon as it's daytime, he ducks across the border and goes and hides in thick bush in Mozambique. So this ability to know where it's safe and where it's unsafe, and also what we're doing as their greatest enemy, makes elephants very adaptable. They're also very smart at using the environment. So we still focused on that area, Kruger National Park, and then Limpopo in Mozambique, Benin, and Zanav. These are all protected areas in Mozambique. And you could see the track of one bull. If you just look at the map on the left side of the screen, you can see that outside of Benin, there's two knotted areas with a lot of daytime movement, but it's not a lot of space that's being covered by that movement. If you then layer this map with the vegetation cover, you can see that animals that are in unsafe areas often hide out during the day for the entire day in very thick bush where they can hide from people, and they don't move over a wide area, but then as soon as it's nighttime, they'll start moving like crazy to get all the resources that they need. And that's an adaptation to a fear landscape. So elephants' spatial and temporal awareness of where it's safe and unsafe can be used to show you what is happening on the landscape. If we look at that map to the right-hand side of the slide, we've got what we call the donut effect, where elephants are actually telling us where they're feeling unsafe or safe, and they're avoiding areas or villages where there might be a lot of poachers. So they just don't go there because they know it's unsafe. And if we look at this one particular individual's movement, so we've got Kruger National Park in South Africa, and then we've got Limpopo National Park in Mozambique. You can see the movements in Kruger Park are totally different to those in Mozambique. So in Kruger, elephant's more relaxed, and it's got a more balanced ratio of day-night movement. It's also got movement where they turn back on themselves. It's not very directional. They call that very tortuous movement. But as soon as that animal crosses into Mozambique, the movements become very directional, much less movement at night, which is quite incredible and a very smart way to adapt to a fear landscape. So I think if we look at an area like Great Limpopo Transfrontier Park, which spreads across Zimbabwe, South Africa, and Mozambique, and we overlay with those protected areas and also the areas outside of the protected areas, all the elephants that we've collared together with our colleagues from Mozambique and from Gororin Zoo, we can see the orange areas are the cows that have been collared, and they're far more site faithful than the bulls. The bulls are the blue areas. So the cows are very risk adverse, which makes a lot of sense. They're worried about the smaller individuals, but the bulls go everywhere. And as I showed you previously, they do most of these risky movements at night. But if we look at this entire area over which elephants are moving, it's actually an area the size of Switzerland. And if we look at the population of all these elephants in this area, it's about 50,000 elephants, which represent 12% of the continental population. So it's quite an important population. And then we can also see in terms of size, the protected areas are only making up about 50% of the range over which these animals are moving. And we all know that there's a global 30-30 vision, which means that we need 30% of the land under effective management by 2030 if we want to reach global biodiversity targets. And I think because elephants are smart and they are aware of what we're doing, and they do need large areas to range over, they're showing us that they can be the best landscape planners for us to try and reach these biodiversity targets in future. And it's all because they're clever enough to know when is the best time to access resources and when to avoid people. So thank you, everybody.